Okay, so now we're gonna check on multi-scene how to put the circuit together. So we go up here and hit place and hit component. We're gonna look in groups for sources, power sources, hit AC power, hit OK. I'm gonna place it right over here, corner. Now we're gonna look for the ground, so we go again to sources, power sources, then we're gonna look for this ground right here. We go around and hit OK. Place it right down here. Now we're gonna look for the resistances. So we go to basic, go down here, resistors. Now we're using 680 ohms. Okay, place it over here. And we're also using 330 ohms. Okay, again. Okay, close this. We're going to rotate this just to accommodate the circuit. I'm just going to start connecting the circuits with the components. Okay, so this would be our ground down here, so I want to color that just to know. There we go. Now we're going to place a multimeter by R2, so we have it right there. And rotate that too. Then we have the positive line, we're going to connect that to the positive R2. Now we have the negative line over here. Connect that to the other negative side. Now we're going to look for the oscilloscope. Place it up here. Then we are going to connect the two negatives with a secondary ground. We go up here and in use list, go for ground again. Place it right down here. Connect the grounds. Then we're going to connect the first channel A into positive line over here. Then channel B into this secondary one over here. And now we're going to open our oscilloscope. Put it here on the side, and then I'm going to open our multimeter. Put that right there beside it. Now we'll be running the circuit. Real quick, we're going to stop just to verify everything. So over here, our chosen hertz is 500, and our voltage RMS is 2.828. And we're going to hit OK. Now we're going to run it once more. And this is what you're going to see. We hit stop. And we'll go right down here and kind of manipulate the signal real quick. The frequency that we observed for the first channel was, or both the channels, was 500 hertz. And the relationship frequency has to time is that it's the inverse of time and vice versa. And the RMS value. So now RMS means squared. Our first and most common mathematical method of defining the effective voltage. So now we're going to look for the first voltage peak to peak. So we're going to move these around a little bit. And hit right click, and select trace, channel A, so we're good. Same thing for the second one. Select trace, channel A, perfect. Now we're going to go over here. We're going to hit go to next Y max. So first one like that. Then we click the second one. Do the same. We're gonna go this one to the minimum. There we go. And then down here we'll see our time, which is 1 millisecond. Then we'll see our voltage, which is right about 7.98, which is basically 8 volts. Now we're gonna check for the frequency, so we're basically gonna look for the cycle. So we're gonna move number 1 over here. Select trace again, just to verify that. Okay. Now we're gonna hit set value. We're gonna put 0. Hit OK. That'll be the beginning of the cycle. Now we're gonna go for second channel, and again set value to 0. And then we have our first cycle. Our frequency would be 1 over time, so this is our time for that cycle, which is 2 milliseconds. So 1 over 2 milliseconds is 500 hertz, which we have right here. So now we're going to do the same thing for channel 2. So we're going to go over here, right click, select trace, channel B, hit OK. Same thing for this second cursor. Select trace, channel B, perfect. Okay. So that would be the same one. Okay. Okay, it would be the same frequency. Now we're gonna look for the same for the voltage peak to peak. So we would head over here, go to next max. So then we hit the second one. Go to next Y minimum, and then we have voltage peak to peak for that one. Okay, so our chosen voltage peak to peak is 8 volts. So our peak is 4 volts. So now we're gonna show you guys how to find the voltage RMS, which is right here, how we found it. So really quick. So we take voltage peak to peak divided by 2. Which is 4. 4 to find the VRMS. Multiply 4 times 0.707, and that would give us our VRMS. Okay, so now in order to find time, we would have to divide 1 over our frequency, which is 500. So 1 divided over 500 equals 0.002 milliseconds. So basically 2 milliseconds. So we have that 2 milliseconds right down here. So that would be for the first channel. Now for the second one, go trace again. Channel B. Trace. Channel B. Okay. So it's to find the frequency for our second channel, we would have to take this time right here, 2 milliseconds, and divide it and basically invert it so it's be 1/2 milliseconds. So we're gonna do that over here. 1 divided over 0.002, which is 2 milliseconds, which equals 500 hertz. Or 500 hertz, which is right over here. Okay, so we want to make sure before anything to have our multimeter reading sinusoidal waveforms. That would be our voltage for the wave.
Hey, how you guys doing? My name is Rohan. I'm here to tell you guys how to set up an AC circuit on the breadboard and using the Oscilloscope, the multimeter, and the function generator. First off, you want to set up a circuit using 2 resistors. Resistor 1 is going to be the 330, which is going to be the orange-brown. You want to set it up on the board. And then the second resistor is you want to use 680, which is going to be the blue-gray-brown. You set it up in a series circuit, so set the blue side first. Second, you just want to get your wires, all 3 wires. You're going to need 6 wires total on the breadboard. You're going to need a power for your power source and a ground. So this is your power source here, and then also you're going to need a input source. So this is going to be one here, one ground there. So one power source, one input source here for the power. Then you're going to need to get another ground here. Alright, and then next what you want to do is just turn on the oscilloscope, multimeter, and the function generator. Then you want to hook up into channel. You have 2 channels. Let's go to channel 2. And then go to the other one. Channel 1. Alright. Then you'd want to plug in another probe here, which is this is going to go into the function generator, and you're going to put it into the 50 ohm output. Right. Then you have 2 last wires left. This is going into the multimeter. You got power voltage here, and then you have a ground source. Just plug it into here. Right. Now, you also want to plug in from multimeter. You want to go into the power here, so one end of the resistor. And then you take from another probe from the function generator. No, from the oscilloscope. That's going to go into the other end here. Clip onto the resistor there, which is going to be the 680. Then you'd want to ground it out. Right. So you have signal coming in, and you also have your ground going out. So then you plug in the other one here. The other probe here, that's going to go to your... Next, you plug in from channel 1. This is going to measure the input, so you plug in the probe to the power source here, and the ground to ground. There we go. Then you got your ground coming into the multimeter. This is going to be grounded out here to the power source. Then, cut. Good. Plugging the ground into here. There we go. And last part. This is coming from this wire right here. Is coming from the function generator, which is supplying power. Ground. Plug them into there. Also, want to set the frequency to 500, which is right about here. And you also want to make sure that you have your multimeter set to AC. Alright. Oh. The next part you want to do is you want to flip the switch. Make sure you have everything on channel 1 set. You have your AC circuit set here, and your frequencies, make sure it's correct to 500. And then Yep, that's how you set up a function generator. Right over.
Hello guys, my name is Paul. I will show you how to do the old school method utilizing a digital oscilloscope with two channels. First, we will measure the voltage source. Here you will press channel 1. You go to measure, press voltage. We'll first check the voltage peak to peak in the circuit. You go here, voltage peak to peak. You push this button and you get in here. PPP is equal to 8.08. It's pretty close to 8 volts peak to peak. So now I will show you guys how to get the VRMS. Same button, you measure, you go here voltage, you go down where it says in the menu VRMS, what is voltage root mean square. You push the same button, the knob, and you get it at the side. VRMS is equal to 2.77 volts. As you can see in the same menu display, you can get the VPP and the VRMS at the same time. Okay guys, now I will show you how to measure the time and how to measure frequency. First, you need to clear this out. You see in here, clear, you press that one, as you can see it's gone. Now we'll press time. And here you have multiple choices. You have period to measure frequency, rise time, fall time. We'll move the knob and go out to frequency. You push the same knob and you got it at the bottom. Frequency is equal to 495, 500 hertz. It's pretty close. Now we'll measure also the time. We go to time again, go to period, you push the same knob. It's right here. It's 2 milliseconds basically, so which is pretty close. And as I showed you before with the voltage VRMS and the voltage peak to peak, we have both in the same display, which is the process of taking different measurements at the same time, utilizing this old school method. Yeah guys, now we're taking the same measurements, but this time across R2. First, we need to clean out the display, take out those numbers to be able to measure new numbers. So first, we'll press clear. Now, we just want to change the source, channel 1 to channel 2. Press there. As you can see, now it says channel 2. Now, we'll take out the channel 1 twice. You press channel 2 now. As you can see, it says coupling AC. You need to make sure that those settings are the same, that didn't change. Now you'll press measure. You see the source says CH1, channel 1. You need to change that to channel 2 to be able to take those measurements. Channel 2. Now we'll do the same thing. This time we'll press voltage. We'll check first voltage peak to peak. Pushing up, you get voltage peak to peak is equal to 2.64 volts. Now we'll check to the VRMS. You go there, the knob, what it says VRMS, push the knob, same values. Here the VRMS voltage root mean square is 912.13 millivolts. So now, as we did with the voltage VRMS, with the voltage peak to peak, we'll do the same with time and frequency. When it's, as I did before, we need to clean the display first. We press clear, it's gone. Now you will press time. You will see period, frequency, rise time, fall time, as I showed you before. So press the knob and period. It's right here on the corner, bottom left corner. It says that it's 2 milliseconds. We press time again. And now we'll move the knob and go down to frequency. You push the knob and you get the frequency at the side, which is 500 hertz. So something extra that I wanted to show you is that you can see both channels at the same time in the display. I will show you how to do it. You press channel 1. Now you have the second sine wave in the display too. But if you want to see the same values, the values that we measured before, like voltage peak to peak, VRMS of the channel 1, which is the voltage source. Let's go press channel 1, you see the sine wave, you press measure. Here you change the source to channel 1 and you press, let's say, time. Every time you want to see the period and frequency of that channel 1, so you press it up and you do it again. Time, you go to frequency, you push it up. As you can see them at the bottom, but it's kind of hard to read them because as they appear, the other one just scroll to the side. This is the disadvantage that it has at the time comparing them to the new school method. The new school method, which Connor will show you later, you can see all the values in the same chart at the same time. You don't have to go one by one, and you can see even both channels, which is process of taking new measurements. And this is college level talking. If we go to the industry or the workforce, you have deadlines to meet, you have more equipment, you have more measurements to take. So this old school method will be a disadvantage at the time of taking those measurements, which can lead to delays in the workforce, project development. So I personally don't recommend this method for the workforce. So as a summary, I just want to talk about this method, the one that we did right now, the old school method versus the new school method, the one that Connor will show you later on. The disadvantage of this method over the new school method is that you need to take values measurements one by one, which can delay the performance of a job. Let's say related to the workforce, for example. Here we're talking college level, but in the workforce you have deadlines that you have to meet. You need to work on teamwork. You basically will have more equipment, more items or products that you have to troubleshoot or measure. So what I recommend, I personally don't recommend this type of method for the workforce, but I'll recommend you guys to learn both of them so that you can understand the theory behind it and how it works. This is Paul Rivera Torres. Thank you for watching.
New school method of retrieving data from a digital oscilloscope. Now, as you saw in the last section of the video, the old school method is when you look and observe the waveform and then look at each individual piece of data that you want to look at. What we're going to do here is we're going to select the channel that we want to view. This is channel 1, and we're going to hit measure. And this display all button, we're going to turn that on. Now we're going to look at the voltage peak-to-peak value, the VRMS value, the time, and the frequency. The voltage peak-to-peak is 8.08 volts. The VRMS is 2.8 volts. The frequency is 500 hertz. And the period or time is exactly 2 milliseconds. Look at the voltage values across the second resistor. The second resistor that we're looking at is a 330 ohm resistor, whereas the first channel that we were looking at was measuring the whole circuit. So what we're going to do to begin observing this data is we're going to first clear out the table on channel 1. So I'm going to hit display all off. Now I'm going to double click channel 1 to remove it. I'm going to hit channel 2. Now what I'm going to do is I'm going to hit measure. I'm going to change the channel to channel 2. I'm going to hit display all. I'm going to turn that on. Now we're going to take a look at the same values that we looked across the first channel. And the voltage peak-to-peak is 2.60 volts. The VRMS is 878 millivolts. The period or time is 2 milliseconds. And the frequency is 500 hertz. Now what we're going to take a look at is if I change the frequency on the function generator from 500 hertz to 800 hertz, you'll notice it will not have an effect on the amplitude of the waveform. Change that to 800 hertz. Now we're going to look at the same values. The voltage peak-to-peak is once again 2.6 volts. The VRMS is 880 millivolts. The period is 1.2 milliseconds, but it is very close. And the frequency is 790 hertz, which is pretty much 800 hertz. The reason why we might want to use the new school method versus the old school method is because the new school method it's a lot less time consuming than doing the old school method. As you can see, all the values are just right there. The only downfall of it versus the old school method is that if there's, it's hard to see all the values because they're all right next to each other. Whereas with the old school method, you can see each value individually. Now to go over the values that we measured, the voltage peak-to-peak value of a sine wave is the amount of waveform observed from the positive peak to the negative peak of a waveform. It is twice the voltage peak value. The equation 2Vp can be used to find the voltage peak-to-peak value. The peak value of a waveform is the magnitude of the waveform taken from the center of the waveform to either the positive or the negative peak. The two main pieces of information that define a waveform are amplitude expressed as voltage peak to peak and frequency. The frequency that we observed for the first channel was, or both the channels, was 500 hertz, and the relationship frequency has to time is that it's the inverse of time and vice versa. And the VRMS value, RMS means root mean squared, and refers to the most common mathematical method of defining the effective voltage or current of an AC wave. I'm Connor Tudens. Thank you for watching this.